Okay. Hello. Right, let's get started. So hopefully everyone's here for synchronization of NSX distributed firewall to gateway firewall. So I'll just introduce myself. I'll try and introduce myself. So I'm Nigel Wright. I've worked in the IT industry for over 20 years, which, as my daughter says, means I'm old. I go with middle-aged, but I started off in critical national infrastructure, UK secure government, but for the last 14 years I've worked in the service provider industry. And I've got a focus on infrastructure architecture and automation. It's got a very brief marketing slide. I'll try not to talk about it too much, but I work for a company called Ensono. We're a Broadcom Pinnacle partner, and we provide IT managed services across mainframe, private cloud, public cloud, as well as some consulting and advisory and application development. But the key takeaway for this presentation is almost half our revenue comes from mainframe managed services. So we've built a private cloud platform that tightly integrates physical devices, servers, mainframes, and virtual machines in the same security policy. So we try to run one security policy for all our client environments. Which brings us to why do we want to synchronize the distributed firewall to the gateway firewall. So hopefully you can see this okay on the screen. It's a bit blurred. But on the right we have a T1 connected to an upstream T0, and that T1 is a distributed router only T1. There's no service router, and that's where we connect our overlay segments, where all our VMs are connected to. And for these, obviously, we use the distributed firewall. On the left, we have another T1, which is instantiated on an edge cluster, so it has a service router, and that service router runs a gateway firewall policy. And we attach our VLANs to that T1 to a service interface. So that T1 is acting as a layer 3 firewall for all our physical devices. And obviously, we would like to have that gateway firewall and the distributed firewall running the same policy. So our goal is to have one security policy consistently across virtual machines and physical devices. The difference is virtual machines, obviously distributed firewall is enforced at the VNet level. For the physical servers, we can't enforce the same thing, but we enforce the same policy at the layer 3 gateway. So we can't control traffic between two physical servers on the same VLAN, but we can control it between VLANs and definitely between VMs and physical servers. So, what does NSX do for us that's good? All security groups can be consistently applied across distributed firewall and gateway firewall. So that's tag-based security groups, IP-based groups. All security groups can be applied, which is great. Context profiles can be applied to both the gateway and distributed firewall, also good. However, most services can be applied consistently on distributed and gateway firewall, which leads us to the bad. We're still running NSX 3.2, so this is the situation for us. Distributed firewall implements certain application layer gateways. The UI lets you apply them to the gateway firewall right up till you hit publish and you get this lovely error message. So NSXT doesn't support the application layer gateways for MSRPC, Sun RPC, and Oracle TNS Listener. So what that means is those application layer gateways listen for the initial connection. The return response says, come back and talk to me on, say, port 50,000. And the distributed firewall will open that port for that connection. So unfortunately, we lose that functionality. So we have to create replacement hard-coded services. So for MSRPC, it's 1024 to 5000 and 50,000 upwards, and we have to create those and swap them when we sync. I'll use air quotes, but this is fixed in NSX 4.1. I haven't looked at it yet, but my assumption is all they mean is you can't select them in the UI anymore. And then we get to the really ugly. Let's play spot the difference. These are the dialog box for adding a destination group to a firewall rule. Hands up who can spot the difference. The top one is the gateway firewall dialog box. This is a distributed firewall box. So distributed firewall implements a negate, so a not. So a common use of this is RFC 1918 address space, so 10.172.16, 192.168 are private addresses, so not private addresses can generally mean the internet. Unfortunately, this just doesn't exist in the gateway firewall. So the only fix we have is to take out any negated destination or source and make it an any. It's the only workaround we can come up with that works in all scenarios. So let's see how this works. And this is where we pray to the demo gods. So I'm also going to have to work slightly sideways here now. So what we have here are two views of the same NSX manager. This is the distributed firewall section with quite a few policies, and this is the gateway firewall section for one of our VLAN T1s. So this is out of the box. There are no policies assigned. So what we do, we have a bit of code, and this is available. There's a link in the end of the slide. We run PowerShell. So hands up who's familiar with PowerShell. And then we run terraform. Again, who's familiar with terraform? Reasonable. So essentially, first thing we do, we log in to NSX. So we make sure we can log in, so we error out. We build up a folder structure. And then this is Terraform best practice. We don't write usernames and passwords into files. We write them into environment variables, which we can then call. And then the first thing we do is we initialize Terraform. So we go off to the Terraform provider, so you need internet access, pulls down the latest Terraform provider, and then we sync the security groups. So we have a set of standard services here. So what you can see, we have definitions for our Oracle TNS listener. We just put V2 at the end of everything. So some RPC, you've got the standard port, which is 111, and then these are generally the range of high number port it's open. So we're actually relaxing the security policy quite a bit just for this flow, because we're saying always open these ports. Same for Oracle TNS. Oracle TNS, you need to talk to your application teams because it's entirely up to them what they set. Microsoft RPC is very well defined, quite straightforward. So we run Terraform to make those security groups appear. We do that all the time just to make sure they're there because we need to use them later on. We then make an API call to get all the services from the NSX manager because we need to refer to their API paths later. And then we get all the policies, and then finally all the rules within each of those policies. And we create an ordered list because it's vital that we maintain rule order when we sync across. And then finally, we process all our tier 1 gateways. We remove anything that doesn't have a gateway firewall enabled. And also, we import a list of T1s we want to exclude. So you can do any filtering you want to do. So we'll only apply to 3 gateway firewalls here. And then we'll just scroll down a little bit more. some of the highlights. One of the other challenges we have, the gateway firewall keeps its sequence number order differently than the distributed firewall. So we have to understand the different firewall categories, give them different ranges to work in. So we start with 20,000, 40,000, 60,000. And then we create a hash table of all the new rules. We have to make things lowercase and a few other things for Terraform. And this is where we start taking any negated source or destination or any service, first of all, any service or anything that's any, Terraform just wants to see blank, so we have to take those out. And then finally at the bottom, if we see a negate on the source or destination, we just take that out and put it in, replace it with an any. And then we finally have one trap. If we've got anything with a firewall action of drop, so if it used to be, hey, we can get to the internet, drop it, we're now going to replace that with any. So you can imagine that we're now going to say, you've got a source group, we're now saying, if that's going to talk to anything, drop it. So unfortunately, we have to remove those rules. Otherwise, we'll get some unexpected behavior. And then finally, this is the default layer 3 policy. And that's the sequence number in the distributed firewall. That's as high as the sequence number goes in the gateway firewall. So we give it the highest number to make sure it's at the bottom. I should also mention we take out the layer 2 default policy category because it doesn't apply to a layer 3 firewall. And then what we do is we loop through and we create a Terraform file per gateway firewall that we're going to apply to. We create a hash table and then we merge that in with a template using a PowerShell module called Postash, which is just a mustache implementation. So who's aware of what mustache is or ginger? Okay, thank you. So this is essentially a template of a Terraform snippet, and various parameters are double curly bracketed or mustached. So you merge that with a JSON document that basically says replace that with the variable destination excluded, and it just works through and creates a raw Terraform, which we then apply. So now we will really tweak the tail of the demo gods and see if this works. So the first thing we need to do, we need to create a credential object, a PowerShell credential object, because we don't like leaving usernames and passwords around. So that's created a PowerShell credential object. So now we'll pass that So what this will do, it'll populate all the folders, create and populate all the folders at the top. It's now going off and initializing Terraform. And the first thing it's going to do is sync our standard services. It's found 3 tier 1 gateways, and it's now syncing the gateway policies to that. So we've created our 6 services, and we've created 21 firewall policies. So that's 3 gateway firewalls, 7 policy sections. So if we go and have a look at our gateway firewall and do a refresh, we'll now see that all our firewall rules have appeared. So there's a couple of things to note. So if you look in here, we'll see that these are the V2 services, so these are replacement services. If we look in the distributed firewall, you'll see that these are still the originals. So we've replaced those services. Also in internet access, as I said, you can use RFC 1918 negated to mean the internet. So we have that there. We have that negated RFC 1918. If we go to there, we've replaced that with an any. So essentially we have exactly the same core policy on the gateway firewall we had on the distributed firewall. And as you saw, it was pretty quick to do. We've maintained rule order, and we can actually maintain rule order once I've found the mouse cursor, even if all we do is change a rule order. So what we'll do is we'll move this rule that's why. Can only change rules in the category view. So we've changed that rule order. We publish. And then we run again. This should be quicker because we don't have to initialize terraform. But we'll always go and make sure those standard services are there. I said should be, I didn't guarantee. We'll always make sure those standard services are there. Then we'll do the gateway firewalls. And you should see 3 policies have changed. So that's that Kibana policy we changed. It's only changed those. All the other rules have been left in place. Rule IDs are maintained, so we don't impact logging or established sessions. And as you can see, it basically works with the limitations that we have with NSX. So obviously, that's our demo. As you can see, it works. Please do take the survey. There's a link here to the code in GitHub, and that's my LinkedIn details if anyone wants to contact me. So if there are any questions, if you stick your hand up and we'll get a mic to you. Yes, sir. Someone's just coming with a mic.
Test. Hi, Oliver speaking. When I have policies on the DFW and on the tier 1 and or tier 0 gateways, then I need to expect that the performance might get a little bit worse, right? Because the CPU needs to go over more rules, a little bit more latency and something like that might be expected, right?
Yes. So essentially, my understanding of the question, the way firewalls work, they work in sequence. Every new flow, they go from the top and they work down every rule. At the moment, we do copy every rule to the gateway firewall. None of our firewall policies have reached a size that we worry excessively. However, one of the enhancements we do want to look at is looking at each tier 1 and its routing table, and then make the API call to NSX to populate all the groups to their IP address. See if IP addresses in the local routing table of the T1 are in either source or destination, and only then put that rule there. So we anticipate this and we have an idea. It's just an awful lot of work, and it will slow the process down. At the moment, we haven't seen a need to do it, but it is in our to-do list if we need to. Thank you. Right, if there are no other questions, thank you very much for your time. I hope you enjoyed the rest of the event. Thank you.